Alright, we are going to do a little division today. Alright, the first one, what we're going to do is we're going to divide by a monomial. That's the easiest one. I'm just going to make something up here. Nah, I tell you what, I'll take one right from the book. Let me find a good one. Nice easy one to start with. Let's do this one. Here we go. Ready? Write this down. This is a little bit long, but it's not that long. It's 12 r squared s squared. That little thing, that little blob right there is a squared, plus 20, and then it's rs cubed, and it's all over 4rs, 4rs. Okay, there it is. And it will say, it says perform each division, or we'll just say divide. Alright, so that's what we're doing right here. So it's a division problem. Now look at this. It's a monomial, isn't it? It's a one term. Now you say, well, that's not one term. There's three things in there. But remember, a monomial is just if it's all being multiplied together, something, there's no addition or subtraction. What about the top? What would I call the top? What kind of polynomial? Trinomial, right, because that would be one term. They're separated by minus signs and plus signs. Alright, so I got a trinomial on the top, I got a monomial, one term, on the bottom. That's the easiest kind. So when you do a division problem, what you're doing, everything on the top is being divided by 4rs. So that is being divided by 4rs, so is that term, and so is that term. You don't have to put the arrows on there, I'm just doing that. If you want to, you can. But everything's being divided by 4rs. Some of you can do this problem without doing what I'm going to do next, but I think it might be kind of helpful at the beginning. Okay, you don't have to always do this, but I think for a lot of people it helps. So if everything's being divided by 4rs, let's just make 3 separate little problems. And for some people, I think it's a lot easier. It's a little more writing. We just have to write this down again. But watch, I'm going to put that over 4rs. And then look at my sign that separates these. That's a minus, so I put a minus right here. And then I put the second term, 12r squared s squared, and divide that by 4rs. Then put my next sign. See, they're all separated by either plus or a minus. Follow what I'm doing so far? Yes? No? Maybe? Maybe? See, everything's just being divided by 4rs. Look, if we went the other way, look what I have. I got a common denominator, don't I? So I could put everything over that one common denominator. Thank you. So I could put everything over that one common denominator. I'm just kind of going the other way. I got the one common denominator, but I'm splitting them up into 3. Just because it makes my division a little bit easier. I'll tell you what. Add a little color here. It's getting a little boring, isn't it? All right, what are we going to do here? Let's do some division. So look what we got. I got negative 8 on the top and 4 on the bottom. So what's that going to become? 4 goes into 4 once, 4 goes into 8 2 times, right? So 2 times. So that's a negative 2, right, on the top. What about the r's?
R squared.
It's r squared. Good, because one of these, right, that's a 1. Remember we talked about this, the division rule or the quotient rule. You subtract the exponents. Or sometimes I'll look at it like this. I got 1 r on the bottom. 1 r on the bottom will cancel with just 1 r on the top. So how many do I have left over? I got 2 of them, so that's an r squared. All right, I like to look at it like that sometimes. What about here? I got an s on the top and an s on the bottom. They just cancel out. Right. So this one right here just became negative 2r squared. Are we finished?
Nope.
No, we got to do this other term. We got to do it 2 more times. So look at this. 12 divided by 4. That's 3. That canceled. What about this? One of these r's cancels into one of these. I just have 1 left over. What about this? One of these s's goes into one of these. I got 1 left over. There it is. Minus 3rs. Good with that? That's pretty easy, isn't it? This hasn't been hard. It's just little simplification kind of stuff. Look at this. They rigged these too, didn't they? Because they made everything divide evenly. So 4 goes once, 4 goes what? 5 times. Good. So we got a 5. And what about the r's? They both just cancel out. And what about the s's? One of these goes into one of these, so you get s squared. All right? Now take a look. Always look at the very end before you circle it and decide, can you keep it like that? Yeah, there's no like terms. This has r squared, this has rs, and this has s squared. So none of them are like terms, so there's nothing else I can do with that, and that would be my answer right there. So that's how you divide by a monomial. Pretty simple. But just remember it, because we're going to learn how to divide by a binomial here in a second. And for some reason, on tests and quizzes, I see students try to divide these monomials the same way we do a binomial, and they make it way more complicated. Okay, this is the easiest way, I think. All right, this is about the easiest way you can divide when you just have a monomial. All right, nothing's being added or subtracted on the bottom. All right, you only have one term on the bottom, so you just take everything on the top, divide it by that one term on the bottom. Make sense? I think we're okay with that, right? It's not that big of a deal. So what we're going to do now is we're going to learn how to divide by a binomial. But before we do that, let's go old school. All right, and let's do a old-fashioned long division problem with no calculator. All right, so you're back in, I don't know when you did this, 5th grade, I think, maybe. Is that when you did fractions? I can't remember. I guess it could be different for depending on what school you went to, but it was probably around 4th, 5th grade, I would guess. It's when you did long division. All right, so let's do this. Let's go 7 over 8. Or that could be 7 divided by 8, right? Isn't that the same thing? Yes? Or you could write it as a long division problem. I had a teacher back in the day, 7th grade, Mrs. Borgness. I talk about Mrs. Borgness every year at this point. Okay? I don't remember all my teachers' names, but I remember her. She seemed like she was ancient back then. I don't even know if she's still alive or not, but she is. She's probably 100 or something. I hope she's not listening. So I remember teaching this. For some reason, I don't know, I was a little dense. I still am a little dense. But for some reason, I could just never remember which one of these went inside this little box right here. And that's what she used to call it. I mean, I think there is a fancy name for it, like the divisor and dividend and all. I don't know. I never really learned it when I was a kid, and to tell you the truth, I don't think it's that important anyway to know which one's which. I just call it inside the box and outside the box. How's that? I'm a simple person, right? I have a simple mind, and that's how I like to think. So she always said the top goes in the box. Box top. For some reason, I can remember box top. That always helped me. Even to this day, I think, oh, top goes in the box. All right, so we're going to put a 7 right here, and then the bottom just goes on the outside. All right. Anybody else like me? You always forgot which one went inside there? Or that was probably just you. You were like that too? Okay, that's the way I was. So what are we going to do here? We're going to do an old-fashioned long division problem. So 8 doesn't go into 7, does it? So we put a couple zeros right here. I don't know. We might even need another one. We'll wait. What are we going to do with that decimal? Bring it up top. When's the last time you did a long division problem? Probably a long time, hasn't it? All right, because what do you always use? You always use a calculator, don't you? All right, so let's do this. So does 8 go into 7? No, it doesn't. But does 8 go into 70? Well, it doesn't go evenly, but it goes what? 8 times? Okay, it goes 8 times. So
70 is less than 7.
right. So 8 times 8 is 64. Now, a lot of times we just put a 64 here, but what are we doing with this 64 and the 70? Subtracting. So make sure you put the subtraction there. The reason I'm doing this because I'm getting like I'm trying to develop a pattern here, a little guide in order to go from regular numbers to polynomials. All right, so follow what we're doing here. You may think, well, why am I doing this? I can just do this in a calculator, but that's not the point. The point is follow the steps, follow the logic behind long division, and we're going to do the same kind of problem, but we're going to do it with letters and variables and well, letters are variables, but exponents and all that good stuff. So let's subtract. 70 minus 64 is 6. And what do we do next? 8 doesn't go into 6. Bring down the 0. I think we will need another 0, won't we? Okay. And you just start the same routine all over again, don't you? You say, how many times does 8 go into 60? Well, it doesn't go evenly, but it does go, what? 7 times? Yeah. So 8 times 7 is 56, and we subtract to 56. Don't forget that minus sign. That minus sign is very important. And now we go ahead and we actually subtract. 60 minus 56 is 4. And then we take the next number, which is a 0, and we drop that down.
It actually does.
Now this does go even, right? 8 goes into 40 how many times? 5 times. 8 times 5 is 40. We subtract it. Now at this point you probably stopped because you know it doesn't, but I'm going to just go all the way. All right? And then 0, so it doesn't go into this. And that's it. That's our answer, 0.875. Everybody's familiar with that, right? A little bit of, I mean, again, it's probably been a while since you've done something like that. Tell you what, this is pretty big, so watch. This is another cool thing I can do, I think. Watch this. Look at that. Is that amazing or what? Isn't that cool? You could never do that on a whiteboard, could you? All right. So what I'm going to do, let's do a long division problem. But we're going to do it with polynomials. We'll do it in a different color. And let me find a nice easy one. There we go. Here's what it will say. It'll say divide. Actually, it might even say divide, but that's okay. It's 3x cubed minus 2x plus 5, and it's over x minus 3. Now, that looks a little different than that, doesn't it? Can you just throw that into a calculator and get an answer? Don't think so. All right. So that's what people say all the time. Mr. Hamrick, why do you keep making us show your work and blah 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 blah? Because you might be able to do this in a calculator, but when it comes to algebra, you got all these letters and exponents and all that kind of thing, and you can't always put it into a calculator. So you got to know how to do things, how to work with fractions, because later on we're going to be doing a lot of fractions that have variables in it that you can't just plug into a calculator. I got nothing against calculators, all right, but I want you to know the process. That's what we're here to do. So we're going to make a long division problem out of this. So I'm going to do this. Now, which one goes in this box? The top, see? You learned it, didn't you? So now when you're real old, you'll say, I had this old teacher, Mr. Hamrick, and he's probably dead by now, but, you know, he was so old when he was my teacher. He's probably ancient now.
Yeah, you're not that old.
Yeah, well, thanks, Tiffany. All right, now here's a little trick to this. They don't, usually on the first example I don't do this, but see how we put in place values for on here? You kind of have to do the same thing here. This is a little bit different, but look what it does. It jumps from x cubed to x to the what? To the first, okay? Now I'm not going to, if I had a whole bunch of time, I'd show you. You need an x squared in there, right? But if I had enough time, I would probably go through and show you. You're going to come up with a roadblock if you don't put the x squared in there, all right? I'm just not going to do that right now because of time, but you need an x squared in there. But you're just like, well, wait a minute, there is no x squared in there. How can I just stick an x squared in there? Well, look, there were no numbers out here, were they? We just made them what? Zeros. So I could make this a what? A 0 x squared. So did I really change the value of it? No, I just added a 0, didn't I? So it didn't really change the value, but it kind of acted as a placeholder, right? It filled up all the places. So I got x cubed, then I have an x squared. Now I can go to the x. So now it's going to be minus 2x, and now I can have my constant. So make sure, whatever your highest power is, you've got to go in order all the way down to the constant. All right? So if I have an x cubed, I have to have an x squared, then an x, and then a constant. Does that make sense? Usually I save that example for maybe like the next one, but I think we're okay with that. Now what goes on the outside of here? X minus 3. Good. Now the reason I wanted to keep this stuff in yellow here is I wanted us to have it right next to us so we can kind of follow the pattern. Now here's what we're going to do. The process is basically the same, but some of the steps are a little bit different, so we got to think a little bit here. So over here, what do? We said, how many times does 8 go into 70, didn't we? All right. So over here, we're going to say, forget the 3 for right now. Just look at the x. Okay? We're going to just look at the x. How many times does x divide into 3x cubed? Sometimes people have to go off to the side, and that's fine. How many times does x divide into 3x cubed? So if I had to divide that, what would I get? Well, it's not just x squared. It's close. It's 3x squared. That's right. It's 3x squared times. So here's the question again. How many times does x divide into 3x cubed? Or I could just say 3x cubed divided by x. That's what we did here, isn't it? We went 70 divided by 8, basically. Right? Didn't come out even, but that's what it was. And this won't come out exactly even because we got that minus 3 there. But I'm saying 3x cubed divided by x is 3x squared. So what did I do here? I said 8 goes into 70 how many times? 8 times. I stuck it up top. So what am I going to do here? X goes into 3x cubed how many times? 3x squared times. Where do I put it? I put it on top. See, I'm following this pattern over here, aren't I? What do we do here once I stuck that 8 on the top? I went 8 times 8, and then I stuck it underneath. So what do you think I'm going to do with this? I'm going to, first of all, I got to multiply it by this thing on the outside, right? Because I went this 8 times this 8. Now this time I will include that minus 3. All right, so now I'm going to go 3x squared times x minus 3, and then I'm going to subtract it. Now watch carefully. I'm going to put a subtraction. Remember how I kept saying don't forget that subtraction? This is very, very important. This is why I told you don't forget the subtraction. So I'm going to put a minus. Now look, I've got to take this and I have to actually distribute it through this, don't I? So it's a little more complicated than what we did over here, but it's the same basic steps. So 3x squared times x is 3x cubed. And then put a minus, and then 3x squared times 3 is 9x squared. Now if it seems like I'm going a little bit quick here, make sure you go on YouTube and watch it. Okay? Pause it, go back until you figure out what I was doing here. Alright, so I took 3x squared and I multiplied it by this whole thing. Basically, what was the step here? I went 8 times 8 is 64 and I subtracted, right? It's basically the same exact step. I went 3x squared times this thing on the outside and I subtracted. Now over here it was easy to 70 minus 64, that was easy. It was 6 and I brought it down. This subtraction is a little more complicated, but let's see what we got. I got 3x cubed minus 3x cubed. What's that? 0. Right? 3x cubed minus 3x cubed is 0. Then I got to go 0x squared minus a negative. What's minus a negative? Talk to me. It's positive. So it's 0x squared, what? Plus 9x squared is 9x squared. So that 64 is kind of like, I'm sorry, the 60 or the 6 right here is kind of like that 9x squared. We're in that same step. Alright, all I did was subtract. Make sure you put it in parentheses because you have to distribute that negative through there. Alright, so it's 3x cubed minus 3x cubed, which is 0. I just didn't write anything down. 0x squared minus a negative is plus 9x squared is 9x squared. Now what did we do here once we got that 6? Brought down the 0, the next number, right? In this case it's not a 0, but we bring down the next number. Just like a regular long division problem. So look at the sign in front of it. It's a minus 2x. Okay? Let's start the routine all over again. And that's what we did over here, isn't it? We brought down the 60. Okay, how many times does 8 go into 60? Well, 7 times. Well, what do we do here? How many times does x go into what? Just the first one, 9x squared. How many times does x divide into 9x squared? Well, 9x, right, 9x, because that goes into that 9x times. So that's the division. It's 9x squared divided by x, which is 9x. It's positive 9x, so we put plus 9x right up here, just like we put the 7 up here. You see how it follows the pattern? Again, it's a little more complicated, I agree, but it follows the same basic pattern. All right, we're almost done. So let's, what do we do? Oh, we got to multiply, then we got to subtract. So this is what I do right off the bat. Over here, what did we do? We went 7 times 8 is 56, and we subtracted 56. So what are we going to do here? We're going to go 9x times this whole thing, x minus 3, and we're going to subtract it. We're going to put it right here. So let's do that. 9x times x is 9x squared. And then 9x times negative 3, which is negative 27x. We're getting there. Only got one more number to bring down, right? So we're almost done. 9x squared minus 9x squared is 0. Now watch this. You got to be careful. Negative 2x minus a negative. Minus a negative is positive, plus. So it's negative 2 plus 27. What's negative 2 plus 27? Positive 25, what? X. All right? Again, go back on YouTube. I promise that's going to be helpful. If you go back, take your time with it, listen to the instructions again, and I think it'll make sense. Now, what did we do here? We got the 56, we subtracted, we got the 4, we brought down the next number. So what are we going to do here? Bring down the next number. And that's a plus 5. Let's do the routine one more time. Now you're starting to get used to it a little bit more, I think. So we say, how many times does x divide into 25x? So I do this off to the side. How many times does x go into 25x? Just 25, right, because the x cancels with this, and I'm just left with 25. Alright, so how many times does x go into 25x? 25 times. I stick that up here. It's a positive, so I put plus 25. And now, it's like this, right? Put it here, multiply, subtract, do the same thing. Let's multiply and subtract. I always like to put this first, and then we can do that. 25 times x is 25x. 25 times negative 3 is negative, what? 75. And let's see, we get 20, oh, that's an x. 25x minus 25x is 0. 5 minus a negative, again, minus a negative is positive. So 5 plus 75 is 80. Now, does x divide into 80? No, because there's no x there. So it doesn't go anymore. Now, this one came out even, didn't it? All right, but this one right here, this is our what? What do we call it in long division? Our remainder. Now, when you're a little kid, you put R80, didn't you? Okay, we're not going to do that, though. Then you grew up a little bit, and then what'd you start doing with that remainder? Like if you had some crazy remainder, let's pretend. Now this problem isn't like this, but let's say the remainder was 3, let's just say, all right? What would you do with that remainder? You would put what? 3, do you remember this? Over 8? I'm just saying if it was a 3, all right? So what do you think we're going to do with this 80? 80 over, put a plus because it's a positive 80, put 80 over x minus 3. And that's just basically our remainder right there. All right, so we don't put the R for remainder. You did that when you were a little kid, when you first started learning how to do stuff. But then you started learning a little bit more about it, and then you put it over what you're dividing by. Now that ugly thing right there is your answer to a long division problem. How about that? Has anybody ever done that before? Did you do that in Algebra 2? Yeah, a lot of times you do that in Algebra 2. All right. There's other ways. Did you remember doing synthetic division? Does that ring a bell? Okay, synthetic division. So there is another way we could do this. I'm not going to go through that right now. We're just going to learn the old-fashioned way. All right, so there it is. I know I only did one example on this, but again, go to the video, watch it all the way through, pause it, rewind it, whatever it takes. Okay, if you think I went a little fast on a step, if you're not really sure. I showed you every little possible thing I could show you, I think, okay, to help you out. All right? All right, I'll give you a worksheet, and then you can get that done. That'll be due on Monday. Wow, we actually have a Monday. That'll be our first Monday, won't it? All right, that's it. Have a good weekend.